Good morning, my dear students. Good morning, one and all. Welcome to the first session of the course. The topic name is Foundations of Data Visualization. We need to talk in the specific introduction module. So, unveiling the foundations of a data visualization and introduction part, we have to concentrate. In today's data-driven world, the ability to understand and communicate insights from vast amounts of information is very crucial part. This is where data visualization comes into play, and it's serving as a powerful tool that transforms the raw data into visually appealing and easily digestible representations. Understand? As part of the lecture, we will delve into the foundations of a data visualization, that's exploring its importance, historical evolution, and the various types we need to talk now. So according to the importance and benefits of a data visualization, we need to discuss now. Data visualization is more than just creating a pretty graphics and charts. At its core, we can say it's about making a complex data more accessible and understandable to a wider audience. Understand? Here are some key reasons why data visualization is essential. We need to talk here. Okay, the first point we need to talk about the clarity and understanding. Visual representations that help in clarifying complex data sets, that's making it easier for individuals to grasp patterns, trends, and relationships within the data. According to the decision making, by representing data visually, decision makers they can quickly interpret information and make informed decisions that based on insights gleaned from the visualizations. The third is a communication. Actual visualization, visualizations, it serves as a universal language that transcends barriers of language and expertise. It's allowing a diverse audiences to comprehend and engage with the data. Fourth point, that is identifying a patterns and trends. Visualizations, it enable analysis to identify the patterns, trends, outliers, and correlations that may not be apparent with examining the raw data level. Finally, beyond storytelling, actual visualizations that have the power to tell compelling stories with the data. It's enabling organizations to convey messages, persuade stakeholders, and drive actions we have to say here. So what are the historical overview and evolution? We need to talk some other points. The roots of a data visualization, it can be traced back centuries with early examples including like maps, charts, and diagrams that used for navigation, exploration, and scientific discovery. However, the modern era of data visualization that began in the 18th and the 19th centuries with the work of statisticians and scientists like, William Playfair and Florence Nightingale. So the advent of computers in the 20th century, it's revolutionized the data visualization. It's allowing for the creation of a sophisticated graphs, charts, and interactive visualization. The rise of a software tools such as like a Tableau, Power BI, and Matplotlib, it further democratized data visualization, and it's making it accessible to a wider audience. It's beyond the data scientists and statisticians, we can say. Some of the types of data visualizations we need to concentrate. Data visualizations come in various forms, and each is suited to the different types of data and analytical codes. Some common types we need to talk, starting from the bar charts and histograms. Ideal for comparing categorical data or visualizing the distribution of continuous variables, we can use the bar charts and histograms. Second will be on a line charts. It's effective for showing trends over time or comparing a multiple data sets. The third will be on a pie charts. It's useful for displaying proportions and percentages within a data set. The fourth will be on a scatter plots. That's helpful for identifying relationships and correlations that between two continuous variables. We are using a scatter plots. Fifth will be on a heat maps. It's very great for visualizing large data sets and identifying the patterns through color gradients. And sixth is tree maps, and useful for visualizing hierarchical data structures such as like file directories or organizational hierarchies, everything. Seventh is interactive visualizations. It enables users to explore data dynamically. It's a drill down into details and again a deeper insights through interactive elements, we have to say here. In a nutshell, we need to say data visualization, it plays a vital role in transforming raw data into actionable insight as a tool, and it's enabling organizations and individuals to make informed decisions, communicate effectively, and unlock the full potential of their data, everything. By understanding its importance, historical evolution, and various types, We can harness the power of data visualizations to navigate the complexities of our data-driven world. Okay, the next will be an mastering data visualization. Some of the principles and the best practices we need to concentrate. In today's data-driven world, the ability to effectively communicate insights through data visualization is a very crucial skill. Whether you are a data analyst, a marketer, or a business leader, understanding the principles and the best practices of a data visualization that can significantly enhance your ability to convey complex information in a very clear and impactful way. As part of the lecture, we will explore some key principles and the best practices that can help you become a master of data visualization. The first will be a Gestalt principles and perception. This is a model. The Gestalt principles that are formulated by German psychologists in the early of the 20th century, and they provide a valuable insights into how humans perceive a visual information. And these principles such as like a proximity, similarity, continuity, closure, and symmetry, and it's explained how our brains organize the visual elements into meaningful patterns and structures. So when designing the data visualizations, it's very essential to leverage these principles to create a very clear and intuitive representations of data. For example, we can say grouping its related data points together can help viewers quickly identify the patterns and relationships. Similarly, we need to say it's aligning elements along a common axis or using a consistent visual cues for similar data categories that can enhance the comprehension and facilitate the comparison too. So understanding how the human brain processes visual information according to Gestalt principles, it can guide the design of data visualizations that are not only aesthetically pleasing but also effectively communicate some of the key insights too. The next will be on some of the color theory and visualization also we need to discuss here. It's also a very important stage nowadays. Color, it applies a crucial role in data visualization. It's influencing both aesthetics and interpretation. And effective use of a color, it can draw attention to important data points. It's a differentiator between the categories and evoke emotions or associations too. So when choosing colors for data visualization, it's a very essential to consider factors such as like a contrast, readability, and the cultural associations. And high contrast color that the combinations can improve readability, especially for individuals with the color vision deficiencies. Additionally, using a limited color palette and avoiding unnecessary embellishments that can prevent a visual clutter and maintain a focus on the data. Furthermore, understanding a color psychology, that process can help in conveying a specific messages or moods through data visualization. For instance, we can say warm colors, it look like red and orange, that can signify urgency or importance, while cool colors like a blue and green, it may evoke a sense of a calm or trust, we have to say. So by applying principles of a color theory thoughtfully, data visualizations, it can effectively leverage and engage viewers and facilitate comprehensions of complex data sets. The next is effective storytelling through data visualizations. At its core, we can say data visualization is about a storytelling, and using a visual elements to communicate a narrative or convey a message here. Effective storytelling in data visualization, it involves more than just presenting numbers and charts. It requires a structuring information in a compelling way that resonates with the audience too. And one key aspect of a storytelling through data visualization is understanding the audience and tailoring the visualization to their needs and preferences. Whether presenting to executives, stakeholders, or the general public, it's adapting the narrative and a level of detail that can ensure that the message resonates with the intended audiences. So another important consideration is the narrative flow of the visualization, we have to say, because by guiding viewers through a logical sequence of information from context and background to insights and conclusions, data visualizations, that process can effectively engage and inform the audience. Moreover, we have to focus incorporating context and real-world examples. That process can add a depth and relevance to the story that is told through the data visualization process. By grounding the data in a familiar scenarios or illustrating its implications on everyday life, storytellers, they can make a complex information more relatable and meaningful. So in a nutshell, we have to focus mastering the principles and the best practices of a data visualization. It empowers individuals and organizations to unlock the full potential of their data by leveraging just data principles to organize visual elements, employing color theory to enhance readability and convey meaning, and crafting compelling narratives. Data visualizations, it can become a powerful tool for communication and decision making. So whether aiming to inform, persuade, or inspire, effective data visualization is essential for making a data-driven insights that's accessible and actionable. Okay, next is very important part, that's navigating the data visualization landscape. Discussion to some of the tools and technologies we have to concentrate. In today's data-driven world, the ability to effectively communicate insights through visualizations is paramount. Whether you are a data scientist, analyst, or a business professional, having the right tools and technologies at your disposal, that process can make all the differences in turning a raw data into actionable insights, as I told. So in this part of the slide, we will explore some popular tools and technologies for a data visualization that discuss their strengths and weaknesses and provide insights into choosing the right tool for the task on hand. So introduction to popular visualizations tools, starting from the Tableau. It's a Tableau. Tableau is a widely used data visualization tool. It's known for its intuitive drag and drop interface and powerful analytics capabilities. It allows users to create interactive dashboards and visualizations without requiring extensive programming language. Tableau, it supports a wide range of data sources and offers its various deployment options, like including like a desktop, server, and online. Okay, second will be on a Power BI, and this is a Power BI. It's developed by Microsoft. Power BI is another popular tool and a popular choice for a data visualization and business intelligence. It offers seamless integrations with the Microsoft, that products like Excel and Azure. That's making it a preferred choice for organizations already invested in the Microsoft ecosystem. Power BI, it provides robust data modeling capabilities and allows users to create interactive reports and dashboards that can be easily shared across the team's levels. Understand? Okay, the next will be on understanding a data visualization libraries we need to concentrate, starting from the D3.js. D3.js, it's short for a data-driven documents. It's a JavaScript library widely used for creating a dynamic and interactive data visualizations in a web browsers. And it provides a high level of flexibility and customization, and it's allowing developers to create a bespoke specializations and visualizations that are tailored to their specific needs. Understand? And D3.js is particularly well suited for projects that requiring a complex and custom visualizations, but may have a deeper learning curve compared to other tools. Okay, the next will be on Matplotlib. That's a Matplotlib. Is a popular data visualization library for Python, widely used in scientific computing and data analysis communities. It provides a MATLAB-like interface and offers a wide range of plotting functions for creating a static, interactive, and animated visualizations. Matplotlib is highly customizable and integrates seamlessly with other Python libraries like NumPy and Pandas. That's making it a versatile choice for a data visualization task in the Python ecosystem. So choosing the right tool for the task, we need to talk and finalize. When it comes to choosing the right tool for a data visualization, several factors that are needed to be considered. Okay, the first will be on a data complexity. Consider the complexity of your data and the type of visualizations required here. So for example, we can say visualizations or quick exploratory analysis tools like a Tableau or Power BI may suffice. Understand? However, for more complex visualizations or custom requirements, using libraries like a D3.js or Matplotlib, that may be more appropriate. So second will be on a user skill level we have to talk. Okay, just to consider the skill level of the users who will be creating and interacting with the data visualizations. Tools like a Tableau, Tableau and Power BI that are designed to be user-friendly, and it's require a minimal programming language. That's making them suitable for a wide range of users. On the other hand, we can say libraries like a D3.js and Matplotlib It may require a more technical expertise and some of the programming skills we need, my dear students. The third point, that is integration and scalability. We need to consider the integration capabilities and the scalability, that requirements of your visualization solutions. Tools like a Tableau and Power BI, it offers seamless integration with the various data sources and platforms, that's making them suitable for enterprise scale deployments. As I told, on libraries like D3.js and Matplotlib, it provide a greater visibility and flexibility, but may require additional deployment effort for integration and scalability. We have to focus more. So in a final conclusion, the choice of a data visualization tool or technology, that depends on the specific requirements of your project, including like a data complexity, user skill level, and integration needs. By understanding the strengths and weaknesses of different tools and technologies, as I have explained on an earlier slide, you can make an informed decision and create a compelling visualizations that will drive a meaningful insights and a decision-making process too. Okay, my dear students, I hope you have enjoyed the introduction part of the topic, foundations of a data visualization. Thank you once again, and thank you, my dear students. Good morning, my dear students. Good morning, one and all. Welcome to the second session of the course. The topic name is Advanced Data Visualization Techniques. We need to talk in the specific lecture module. So mastering advanced data visualization, that's unleashing the power of interactivity. In today's data-driven world, the ability to effectively communicate insights is paramount. Like a data visualization, it serves as a bridge that between a raw data and actionable insights. It's allowing stakeholders to grasp complex information quickly and make informed decisions too. While traditional static visualizations have their place, and advanced data visualization techniques that offer a dynamic and immersive experience that can elevate your data storytelling to new heights. This part of the lecture, we will delve into the world of advanced data visualization, that's focusing specifically on interactive visualizations and how they can be implemented to drive a user engagement and facilitate the deeper exploration of the data. The first point, we need to talk about implementing interactivity for user engagement. Interactivity, it lies at the heart of modern data visualizations by allowing users to interact with the visual elements and empower them to explore data from different angles and that uncover hidden patterns and derive the meaningful insights too. There are several ways to implement interactivity in visualization, starting from the hover effects. Okay, so simply and yet effective hover effects that can provide additional information when users hover over the data points or elements. And this can range from displaying the tooltips with the specific data values to highlighting related data points for contextual understanding. Second will be on click events that enable users to drill down into specific data subsets or toggle that between the different views within a visualization. For example, we can say clicking on a particular category in the bar chart that could filter the data to show only relevant information for that category. That's also called, we can say, a click events. The third will be on brushing and linking, and this technique, it allows users to select and manipulate multiple data points simultaneously. By brushing over a certain area in a scatter plot, users, they can highlight the corresponding data points in other linked visualizations. That's facilitating a comparative analysis, we have to say. The fourth will be an interactive filters. It's providing interactive filter controls. It empowers users to customize their viewing experience that's based on a specific criteria or parameters. And this could include like a sliders, a drop-down menus, or checkboxes to dynamically adjust the displayed data. So second will be on creating interactive dashboards. We need to talk. Interactive dashboards that serves as comprehensive hubs for data exploration. As I told on a yearly lecture, that's introduction lecture, that's bringing together multiple visualizations and allowing users to interact with them in a cohesive environment. When designing interactive dashboards, just to consider the following best practices, my dear students, starting from the storyboarding and just to plan the layout and the flow of the dashboard to ensure a logical sequence of information presentation. And we need to arrange visualizations in a way that guides users through the data story and facilitates the intuitive exploration. The second will be on a responsive design, and so that a dashboard is responsive tools that across various devices and screen sizes, and just adaptive layouts and the flexible design elements that will enhance the usability and accessibility for all users. The third will be on a performance optimization. Just optimize the dashboard's performance to ensure a smooth interactivity. That especially when dealing with the large data sets or complex visualizations. Techniques such as like data aggregation, lazy loading, and asynchronous rendering, that process can help improve responsiveness here. The fourth will be embedding external content. We need to enhance the richness of the dashboard by embedding external content such as like interactive maps, live data feeds, or multimedia elements. And this process can provide additional context and insights for users here. Okay, next will be an advanced interactive with JavaScript libraries. JavaScript libraries, it offer a wealth of advanced features and functionalities for creating interactive data visualizations. As I told on the introduction part lecture, some popular libraries include like D3.js, Plotty.js, and HighCharts. Here are some advanced interactive techniques you can implement using these libraries. First will be on a dynamic data updates. Just utilize libraries capabilities to dynamically update visualizations in real time as underlying data changes. And this could involve animating transitions between the data states or streaming a live data for continuous updates. Second will be on a custom interactions. Leverage the flexibility of a JavaScript libraries to create custom interactions that are tailored to your specific visualization needs. This could range from draggable elements for data manipulation to gesture-based interactions for mobile devices. Okay, the third point, that is integration with external APIs. Just extend the interactivity of your visualizations by integrating external APIs for additional data sources or interactive functionalities. For example, we can say integrating a weather API that could enable users to overlay weather data onto geographic visualizations for contextual insights. The fourth will be a user-generated content. Just explore the possibilities for user-generated content within visualizations, such as like allowing users to annotate data points or save a custom views or share insights within others. This process fosters collaborations and encourages active engagement with the data. So in a conclusion, advanced data visualization techniques that offer a powerful means of engaging users and unlocking deeper insights from data. By harnessing the capabilities of interactive visualizations and leveraging JavaScript libraries for advanced interactivity, you can create immersive data experiences that captivate audience and drive informed decision making. So whether you are building interactive dashboards for business intelligence or crafting exploratory visualizations for data analysis, mastering these techniques will elevate your data storytelling to the next level, my dear students. The next we need to discuss about exploring the world through geospatial data visualization. In today's data-driven world, understanding and visualizing the geographical information is becoming increasingly important across various fields, including like urban planning, environmental science, marketing, and beyond. Geospatial data visualization that offers a powerful way to interpret and communicate complex spatial data effectively. That's why in this part of the slide, we will delve into the realm of geospatial data visualization, that's covering its introduction, mapping techniques, and the tools and the insights it can provide here. So according to the introduction to geospatial data, also known as a spatial data or geographic information, that refers to the data that is associated with a specific location on Earth's surface. And this could include like a latitude and a longitude coordinates, addresses, postal codes, or even more complex data like a satellite imagery and elevation models. Geospatial data that can come from various sources such as like we can say GPS devices, remote sensing technologies, surveys, and social media platforms like Facebook, Twitter, Instagram, and LinkedIn. So understanding and analyzing geospatial data is very essential for making informed decisions in numerous domains. Whether it's analyzing demographic trends and studying natural disasters or planning transportation routes, geospatial data that provides crucial insights into spatial patterns and relationships. So according to some of the mapping techniques and tools we have to talk. Okay, the mapping is a very important stage. It's a fundamental aspect of geospatial data visualization. And there are several techniques and tools that are available to create a meaningful and informative maps. Okay, the first will be on a geographic information systems. The short code is GIS. Geographical information system, that software allows users to analyze, visualize, and interpret the geospatial data Popular GIS tools include like ArcGIS, QGIS, and MapInfo. These are some example I have say here. Second will be on a web mapping services, that is a WMS. Web mapping services, that is a WMS platforms like Google Maps, Mapbox, and OpenStreetMap that provide interactive mapping capabilities for displaying geospatial data on the web. Okay, it's also some example. The third will be a data visualization libraries, as I told on a earlier part. Libraries such as like Matplotlib and Plotly and D3.js that offer powerful tools for creating a custom visualizations of a geospatial data within a programming environments like a Python or JavaScript, we can say. Fourth will be remote sensing. Remote sensing technologies including like satellite imagery and aerial photography. It enables the collection of larger scale geospatial data for various applications such as like land use mapping and environmental monitoring and disaster management. Okay, the next will be on visualizing geospatial data for insights. We have to concentrate. Geospatial data visualization, it serves as a bridge that between raw data and actionable insights. By visually representing a spatial relationships and patterns, it helps users uncover trends, identify anomalies, and make a data-driven decisions too. Here are some examples of how geospatial data visualization that can provide a valuable insights, starting from the urban planning. Visualizing demographics data such as like population density, income levels, and infrastructure distribution. This process can aid urban planners in making informed decisions about city development, resource allocation, and public services too. Second will be an environmental science, that's mapping environmental variables such as like a temperature, precipitation, and air quality. It allows the researchers to study climate patterns and climate changes analysis, track the environmental changes, and assess the impact of human activities on ecosystems. That's based on a sustainability process. Third will be a marketing and retail, analyzing a location-based data. Okay, that's a location-based research analysis, such as like customer demographics, competitor locations, and foot traffic patterns that help businesses optimize a market strategy, site selection, and product placement too. And fourth will be on epidemiology, that's mapping the spread of infectious diseases, vaccination coverage, and healthcare resources that assist public health officials in disease surveillance, outbreak response, and resource allocation during a health emergencies. We can say example like a COVID-19 pandemics, they are using epidemiology. So in conclusion, we can say geospatial data visualization is a powerful tool for understanding the world around us. By leveraging mapping technique and tools to visualize geospatial data, we can give a valuable insights that inform the decision making and drive a positive change across the various domains. So whether you are a city planner, environmental scientist, business analyst, or public health professionals, harnessing the power of geospatial data visualization that can unlock a wealth of knowledge about our planet and its inhabitants too. The final topic, that's unveiling the power of a time series data visualizations, we need to talk. Time series data is a trusted trove of insights that's capturing information across various points in time, from stock prices to weather patterns, and this type of data, it holds a wealth of information waiting to be uncovered. However, we can say it's making sense of time series data that can be a daunting task without the right tools and techniques, my dear students. That's in this part of the slide, we will delve into the world of time series data visualization. It's exploring its intricacies and discovering how it can unveil temporal patterns and trends. So first point, that is understanding the time series data. At its core, we can say time series data is simply a sequence of data points collected, recorded, or measured at a successive and equally spaced intervals. These intervals could be anything from milliseconds to years, and depending on the nature of the data being observed. And time series data that can exhibit various characteristics such as like a trend, seasonality, cyclic patterns, and irregular fluctuations too. For instance, just to consider a daily stock price data set. At each data points, it represents the closing price of a stock at the end of a trading day. By analyzing this data over time, one can discern trends indicating whether the stock's value is increasing, decreasing, or remaining relatively stable. Second will be on a visualizing temporal patterns and trends. Visualizing time series data is a paramount for gaining insights and understanding underlying patterns. Like a traditional line charts are often used to visualize time series data with the time represented on the x-axis and the corresponding values on the y-axis. Okay, this is x-axis and y-axis. So this type of chart, some example, it to provide a clear depiction on how the data changes over time. Additionally, techniques such as like moving averages, which smooth out fluctuations in the data, and it can help identify the trends more effectively. By overlaying moving average lines on the original time series plot, trends that become more apparent, it's aiding in decision making and forecasting level. And the third point, that is a time series forecasting visualization techniques. Time series forecasting, it involves predicting future values. It's based on past observations. Visualization, it applies a crucial role in the process that's helping analysts assess the accuracy of forecasting models and identify the potential areas for improvement. One common technique is to visualize actual values that alongside of forecasted values, it's highlighting any disparities between the two. And this allows analysts to evaluate the performance of forecasting models and adjust them accordingly. Another powerful visualization techniques for time series that forecasting is the use of confidence intervals, and these intervals, it represent the range within which future values are expected to fall with a certain level of confidence. By visualizing these intervals alongside actual data, analysts can gauge the uncertainty associated with their forecast. In conclusion, we have to say time series data visualization is an indispensable tool for uncovering insights, identifying patterns, and making informed decisions. Everything, whether it's understanding historical trends or forecasting future values, visualizing time series that data empowers analysts to extract the valuable information and drive actionable outcomes we can get and we can create, my dear students. Okay, my dear students, I hope you have enjoyed the second session of the topic of advanced data visualization techniques. Thank you once again, and thank you all, my dear students. Good morning, my dear students. Good morning, one and all. Welcome to the third session of the course. The topic name is Data Warehousing Fundamentals. We need to discuss in the specific lecture module. So, unveiling the core concepts of data warehousing 101 level, we need to discuss now. In today's data-driven world, the ability to harness and analyze vast amounts of information is a paramount for businesses to gain a competitive edge. This is where data warehousing comes into play. It's serving as a fundamental component in the realm of data management and analytics. This part of the lecture, we will delve into the foundational aspects of data warehousing. It's providing an insightful introduction to its key concepts, components, and architecture. The first one is we need to talk about the introduction to data warehousing. At its core, we can say data warehousing, it involves the process of collecting, storing, and managing large volumes of structured and unstructured data from various sources to facilitate the efficient analysis and decision-making process too. Unlike the traditional databases that are optimized for transactional processing, data warehouses are designed to support complex queries and analytical operations. Okay, some of the overview of data warehousing concepts we need to discuss now. The first will be on data integration. Data warehousing, it involves integrating data from disparate sources such as like operational databases, legacy systems, external sources, and much more. This ensures a unified view of the organization's data for analysis. Second will be on data transformation. Like a raw data extracted from different sources, it often requires transformations to conform to a common format and structure. And this involves processes like cleaning, filtering, aggregating, and summarizing data to make it suitable for analysis. The third will be on data storage. Data warehouses, it employ a specialized schema. It's optimized for analytical queries. Typically, we can say it organized into dimensions, like descriptive attributes and the facts, that is, we can say like measurable metrics. This schema, known as a star or snowflake schema, it facilitates efficient querying and reporting level. And the fourth will be a data retrieval. So data warehousing, it enables users to query and retrieve data using online analytical processing, that is OLAP tools. OLAP tools. OLAP is online analytical processing. It allows for a multi-dimensional analysis where users can explore data from various perspectives drill down into details, and perform a complex analytical operations process instead. So what are the components of a data warehouse? Starting from the data sources, these are the systems or applications from which data is extracted and loaded into the data warehouses. Like a sources that may include transactional databases, CRM systems, that is a customer relationship management systems, or enterprise resource planning, that is ERP systems, spreadsheets, flat files, etc. we can say. Second will be an ETL, that is a extract, transform, and a load, that is ETL tools. Actually, ETL tools that are used to extract data from a source systems that are transformed into the desired format and load it to the data warehouse. Because popular ETL tools include like Informatica, Talent, Microsoft SSIS, and Apache Spark. Some example I can say here. The third point, that is a data warehouses database. The data warehouse database is the central repository where data is stored for analytical purposes, and it's optimized for read heavy operations, and it typically employs a columnar or MPP, that is massively parallel processing, that architecture for fast query performance we can get from the process. And fourth is a metadata repository. Metadata, or data about data, it plays a crucial role in a data warehousing. A metadata repository stores its information about the structure, that's a format and the meaning of a data elements within the data warehouse, and it's a facilitating a data governance or lineage tracking and a data lineage. Okay, the next is very important concept, that is a data warehousing architecture. Data warehousing architecture typically comprises the following layers, starting from the source system layer. And this layer consists of various operating systems and external data sources from which data is extracted from analysis. Second will be an ETL layer. The ETL layer, it encompasses processes and the tools that's responsible for extracting data from our source systems and transforming it into the desired format and loading it into the data warehouses too. The third will be a data warehouse layer. And actually this layer, access layer, it provides interfaces and tools for users to query, retrieve, and analyze the data stored in the data warehouse. This may include like OLAP tools, reporting tools, dashboards, and ad HOC query interfaces too. So in a short nutshell, we can say data warehousing that forms the cornerstone of a modern data management and analytics. It's empowering organizations to unlock valuable insights from their vast troves of data. By understanding the fundamental concepts, components, and architecture of a data warehousing, businesses they can establish a robust data infrastructure and drive informed decision making in today's data-driven landscape, my dear students. Okay, just to stay tuned for our upcoming lecture part where we will explore some of the advanced topics in data warehousing and analytics. Okay, the next will be on, we need to talk about the demystifying a data modeling for data warehousing. Actually, we have posted a separate course about the data modeling. Here, in the realm of data warehousing, its effective data modeling is the cornerstone upon which robust and efficient systems are built. And it serves as the blueprint for organizing and structuring data that's enabling businesses to derive meaningful insights and make informed decisions too. As part of the lecture, we will delve into the intricacies of data modeling for data warehousing, that's exploring a dimensional modeling versus normalized modeling, the concept of a star schema and a snowflake schema, and some of the techniques for designing effective data models. Okay, according to the dimensional modeling versus normalized modeling, we need to talk. Dimensional modeling and normalized modeling, it represents two distinct approaches to structuring data within a data warehouse. Okay, according to the dimensional modeling, this approach emphasizes simplicity and the use of understanding for end users. It revolves around the creation of fact tables, okay, that contains business metrics or facts, and dimension tables that provide a context for these facts. Actually, dimension tables typically store descriptive attributes such as like a time, a geography, product, and customer information too. We can say some example. And dimensional table and dimensional modeling is well suited for analytical queries and reporting due to its denormalized structure, which simplifies querying and enhances performance. So according to the normalized modeling, we can say in contrast, it follows the traditional database normalization principles that's aiming to reduce the redundancy and improve data integrity by minimizing data duplication. And it involves breaking down the data into separate tables to eliminate redundancy and dependency issues. While normalized modeling, it offers advantages in terms of data consistency and maintenance. That's a very important stage because it may result in a more complex queries and a potentially slower performance for analytical workloads that are compared to dimensional modeling. So according to the star schema and the snowflake schema, we need to talk and complete the process. Both the dimensional and normalized modeling approaches, as I told, it can be implemented using a different schemas or designs. With the star schema and the snowflake schema, there's being two common variations. According to the star schema, the fact table is surrounded by dimensions tables. Okay, dimensions tables in a star like a structure where each dimension table is directly connected to the fact table. This simplicity facilitates a straightforward queries and is conducive to faster query performance. That's making it a popular choice for data warehousing environments. We can say this look like a star schema. Okay, the second will be on a snowflake schema. The snowflake schema that extends the star schema by further normalizing dimension tables. That's leading to a more intricate structure resembling snowflakes. This approach aims to conserve storage space and reduces data redundancy by breaking down a dimension tables into additional related tables. Understand? While snowflake schema, it offers benefits in terms of data consistency and space efficiency, and it may introduce a complexity in query execution due to multiple joins across normalized tables. Okay, some of the techniques for designing effective data models we need to concentrate. Designing effective data models for data warehousing, it involves a blend of art and science. It's incorporating various techniques to meet a specific business requirements and optimize performance. So what are the points under the level? Starting from the requirement analysis. Just to begin by understanding the business requirements and the data sources to identify the key entities, attributes, and relationships that are needed to be represented in the data model. Second will be a normalization and a denormalization. Just to determine the appropriate level of normalization or denormalization, that's based on the balance between the data integrity and the query performance requirements. So third is partitioning and indexing. Implement partitioning and indexing strategies to enhance the query performance, particularly for large data sets. So according to the data governance and quality, just establish the data governance practices to ensure data accuracy, consistency, and compliance with the regularity requirements. Final, that is iterative environment and iterative refinement too. Data modeling is an iterative process that involves continuous refinement based on a feedback from stakeholders and evolving business needs. So in a short conclusion, we have to say data modeling for data warehousing is a multifaceted process that requires a very careful considerations of various factors, including like a modeling techniques, a schema designs, and optimizing strategies, everything. By understanding the nuances of a dimensional modeling that versus a normalized modeling, as well as the differences between a star and a snowflake schemas, businesses they can design effective data models that drive actionable insights and support the informed decision making too. Okay, the next will be on mastering data warehousing. That's unlocking the power of ETL processes and it's some of the tools we need to talk and concentrate. As I told, in the world of data management, efficient extract, transform, and load, that's ETL processes that are the backbone of successful data warehousing. Whether you are a seasoned data professional or just starting your journey into the realm of data warehousing, understanding ETL processes and tools is very crucial for leveraging the full potential of your data. Okay, in this slide, we will delve into the intricacies of ETL processes. Let's explore the various tools available and uncover best practices for ensuring an efficient data flow within your data warehouse. The first will be an overview of ETL. At its core, we can say the ETL process, it involves three key steps, extraction, transformation, and loading. We need to talk one by one. The first will be an extraction. In this step, data is extracted from various sources, okay, such as like databases, applications, or external systems. This could involve pulling data from a structured databases and semi-structured sources like XML or JSON, or even unstructured sources such as like some of the text files too. Second point, that is a transformation. Once the data is extracted, it undergoes a series of transformations to very clean, filter, aggregate, and standardize it. This step is very crucial for ensuring that the data is consistent, accurate, and formatted correctly for analysis process. The third is the load. Finally, we can say the transformed data is loaded into the target data warehouse or data mart, where it can be accessed and analyzed by end users through reporting and analytics tools. So what are the ETL tools and their features? Some of the examples we need to talk. A wide range of ETL tools is available in this market, and each offering its a unique set of failures. Some of the positives and the features and capabilities also available. Some popular ETL tools include, we need to talk about the Informatica Power Center, known for its robustness and scalability. And Informatica Power Center, it offers a comprehensive set of features for designing, executing, and monitoring ETL processes. It supports various data sources and targets, that's along with advanced transformation capabilities. Okay, second will be on a SSIS, that is a Microsoft SQL Server Integration Services. Okay, this is the model that's integrated within the Microsoft SQL Server ecosystem. SSIS, it provides a powerful platform for building ETL solutions. It offers a rich set of data transformation tasks, connectors to various data sources, and scheduling capabilities. The third will be in a Talent Open Studio. Talent Open Studio is an open source ETL tool that provides a user-friendly interface for designing ETL workflows. That's a very important stage. And it offers a wide range of connectors, support for big data platforms, and advanced data quality features too. And the fourth is Apache Spark. While not strictly an ETL tool, Apache Spark is widely used for large scale data processing and ETL tasks. With its in-memory processing capabilities and support for a complex transformation, Spark is well suited for handling massive volumes of data. Okay, some of the best practices for efficient ETL processes we need to discuss now. Okay, to ensure the efficiency and reliability of your ETL processes, we need to consider some of the practices. Starting from the data profiling. Before designing your ETL workflows, perform through the thorough data profiling to understand the structure, quality, and the complexity of your data sources. This process will help identify the potential challenges and inform your transformation logic. Second will be an incremental loading. So whenever possible, implement incremental loading strategies to only process new or modified data since the last ETL run. This reduces processing time and minimizes the impact on the source systems. The third will be on a parallel processing. It's a leverage of parallel processing capabilities. It's offered by your ETL tools to distribute workloads across multiple threads or nodes. And this can significantly improve our performance, especially when dealing with the large data sets, we can say. Fourth will be an error handling and logging. That just implement the robust error handling mechanisms to capture and handle errors gracefully during the ETL processes. And logging of ETL activities and errors is very essential for troubleshooting and auditing purposes. The fifth will be on a data quality checks. Just incorporate data quality checks at various stages of the ETL process to ensure the accuracy, completeness, and the consistency of the transformed data. This includes like validation rules, data profiling, and reconciliation with the source systems. Finally, will be an automation and scheduling. Automate your ETL workflows and schedule them to run at appropriate intervals. That's based on business requirements. This ensures timely updates to the data warehouse and frees up resources for other tasks. So in a conclusion, we can say mastering ETL processes and tools is fundamental for building and maintaining a robust data warehousing solution. By understanding the ETL process, that's exploring the features of different ETL tools and following best practices, organizations can streamline their data integration workflows and unlock the full potential of their data sets. Whether you are embarking on a new data warehousing project or optimizing an existing one, investing in ETL expertise is very important part and important key to driving actionable insights and informed decision-making level. Okay, my dear students, I hope you have enjoyed the third session of the topic of data warehousing fundamentals. Thank you once again, and thank you all my dear students. Good morning, my dear students. Good morning, one and all. Welcome to the fourth session of the course. The topic name is Advanced Data Warehousing Techniques. We need to talk in the specific lecture module. So advanced data warehousing techniques and data quality governance, it's ensuring excellence in a data management, we have to say. In today's data driven world, businesses are constantly seeking innovative ways to harness the power of data to gain a competitive edge. Data warehousing, it has emerged as a cornerstone of a modern business intelligence. It's providing a centralized repository for storing and analyzing vast amounts of data. However, as the volume and the complexity of our data continue to grow, organizations that are faced with the challenge of maintaining high standards of data quality and governance to ensure the level that's achieving excellence in a data management process, we can say here. So starting from the advanced data warehousing techniques we need to discuss now. Data warehousing, it involves the process of collecting, storing and managing data from various sources to support business decision making, as we know. But advanced data warehousing techniques that leverage cutting edge technologies and methodologies to enhance the performance, scalability and the flexibility of data warehouses. Some of the key advanced data warehousing techniques include starting from the columnar storage. Unlike the traditional row-based storage, columnar storage that organize the data by columns rather than rows, it's enabling a faster query performance and a compression level. And this is a very important technique, is particularly beneficial for analytical workloads where queries often involve aggregations and analysis of a specific columns. Second will be on in-memory processing. In-memory processing, it involves storing data in the random access memory, that's a RAM of servers rather than on disk. It's allowing for a faster data retrieval and analysis. By eliminating the needed to access the data from disk, in-memory processing that significantly reduces latency and improves the query performance, that making it ideal for real-time analytics and interactive data exploration. The third will be on a data visualization. Data visualization, it allows the organizations to access and query data from multiple disparate sources without the need for a physical data movement or replication. And this is very important technique. It simplifies the data integration and it provides a unified view of data across the organization, that's enabling faster decision making and improved agility. The fourth is a data lakes integration. Data lakes, it complement the data warehouses by providing a scalable repository for storing a raw and unstructured data such as like logs, sensor data and social media feeds. Advanced data warehousing techniques that involve integrating a data lakes with the data warehouses to leverage the strengths of both platforms. It's enabling organizations to store and analyze the diverse types of data efficiently. The fifth and final, that is a machine learning integration. It's a very important stage nowadays. Machine learning algorithms that can be integrated into data warehouses to automate data cleansing, enrichment and predictive analytic tasks. By leveraging machine learning, and organization can improve data quality, gain a deep understand and insights from their data, and enable advanced analytics capabilities such as like a predictive maintenance and fraud detection too. Okay, the next will be on data quality and governance in data warehousing. It's a very important concept nowadays. Data quality and governance, that are critical aspects of a data warehousing that ensures the reliability, accuracy and the consistency of data across the organization. Because poor data quality, that can lead to erroneous insights and decisions, while inadequate governance, that can result in compliance issues and security breaches. Okay, just let's delve into the importance of data quality and governance in data warehousing and explore some of the key concepts and the techniques also we need to concentrate. The first will be an importance of a data quality in data warehousing. Data quality, it refers to the accuracy and completeness, consistency and reliability of data. In the context of a data warehousing, we can say it's maintaining high standards of data quality is very essential for ensuring that the insights derived from a data analysis are accurate and reliable. As I told, poor data quality, that can lead to erroneous conclusions and decisions that's impacting a business performance and customer satisfaction. Okay, so some of the key reasons why data quality is very important in a data warehousing, starting from the decision making, that's a very important key reason. High quality data, it enables organizations to make informed decisions that's based on accurate insights and analysis. Second will be an operational efficiency. Quality data reduces their time and effort it required for data cleansing and validation, that's improving operational efficiency. The third will be a regulatory compliance with the regulatory requirements such as like a GDPR, HIPAA, and SOX. It requires organizations to maintain accurate and reliable data. Fourth will be a customer satisfaction. Quality data, it ensures that the customer information is accurate and up to date. That's leading to improved customer satisfaction and loyalty. Fifth will be on a risk mitigation. Poor data quality that can increase the risk of errors, fraud, and compliance violations. That's leading to financial and reputational damage. So what are the data governance frameworks? Data governance, it involves the processes, policies, standards, and controls that ensure the effective management and use of data across the organization. A robust data governance framework, it provides the structure and guidance for managing data quality, security, privacy, and compliance. Because some common components of data governance framework, starting from the data governance council, we need to discuss. That's the first and important framework part. A cross-functional team that's responsible for defining a data governance policies, standards, and procedures too. Second may be on data stewardship. It's assigning accountability for data quality and ensuring that data owners and stewards are responsible for maintaining the integrity and accuracy of the data. The third will be on data quality management, establishing processes and tools for measuring, monitoring, and improving data quality throughout its life cycle. Fourth will be on metadata management, managing metadata to provide a comprehensive understanding of a data lineage, definitions, and relationships. Final, that's the data security and privacy. So implementing controls and policies to protect the data from unauthorized access, breaches, and misuse. Okay, the next will be on some of the data quality management techniques we have to talk and identify. Effective data quality management that involves a combination of techniques and best practices to identify, assess, and improve data quality. Some common data quality management techniques include starting from the data profiling. It's analyzing data to identify anomalies, inconsistencies, and inaccuracies. Second, that is data cleansing. It's look like removing or correcting errors, duplicates, and inconsistencies in the data. The third is the data standardization. It's establishing a consistent formats, codes, and definitions for data elements. Fourth is the data validation. It's verifying the accuracy and the completeness of the data through validation rules and checks. Final will be on data monitoring and reporting. So implementing processes to continuously monitor data quality metrics and report on data quality issues. So in a conclusion, we have to say advanced data warehousing techniques that's coupled with the effective data quality and governance practices that are essential for organizations to derive a maximum value from their data sets. By leveraging advanced technologies, implementing robust governance frameworks, and adapting data quality management techniques, organizations they can ensure the reliability, integrity, and usability of their data. That's enabling informed decision making and driving a business success we can do. Okay, the next part, that's unlocking insights, the convergence of a big data and real-time data warehousing we have to talk. That's a very important topic and concepts. Actually, in the ever-evolving landscape of data management, two prominent trends have emerged as game changers. Number one, that is a big data integration in data warehousing, and second, that is real-time data warehousing. Okay, so these innovations have revolutionized the way organizations collect, store, and analyze data. That's paving the way for deeper insights and faster decision-making level. This part of the slide, we will delve into these two topics to understand their significance, challenges, and the technologies that's driving them forward. The first is, a big data integration into data warehousing. The proliferation of a big data technologies such as like Hadoop and Spark has redefined the possibilities of data management. And these platforms enable organizations to process and analyze the massive volumes of data in a distributed and scalable manner. However, integrating a big data with the traditional data warehousing systems that poses several challenges. And actually, one of the key challenges is the disparate nature of data sources. Like a big data platforms that often deal with unstructured or semi-structured data from sources like social media platforms, sensors, and logs, where traditional data warehouses primarily handle the structured data from transactional systems. So this is a major process, and it's bridging this gap. It requires robust integration techniques and technologies. Furthermore, the velocity and the variety of a big data that present challenges in terms of data governance, quality, and security, and traditional data warehousing practices that may not suffice in this context, that are necessitating a new approaches to ensure data integrity and the compliance mode. So, despite these challenges, the benefits of integrating big data with the traditional data warehousing are immense, and it enables organizations to gain a holistic insights by combining structured and unstructured data sources. And moreover, we can say it empowers a data-driven decision making by providing a comprehensive view of business operations and customer interactions to understand. The second point, that is real-time data warehousing. It's also a very important stage. In today's fast-paced business environment, the need for real-time insights is more critical than ever. Real-time data warehousing addresses this need by enabling organizations to ingest, process, and analyze data in a near real time. It's allowing for a timely decision making and proactive responses to events we can take and we can identify. At the heart of real-time data warehousing is the capability for instantaneous data ingestion. Technologies like Apache Kafka and Amazon Kinesis that facilitates the seamless streamlining of data from various sources into the data warehouse. It's eliminating latency and enabling continuous data flow. And architectures for real-time data processing that may vary depending on the specific use case and requirements of the organization, because common approaches that include like a Lambda architecture, which combines batch and stream processing, and a Kappa architecture, which focuses solely on stream processing for simplicity and scalability. So we can focus like a Lambda architecture and a Kappa architecture, everything. As well as technologies such as like Apache Flink and Apache Storm and Apache Spark that streamlining are instrumental in implementing a real-time data processing pipelines. These platforms offer features for stream processing, windowing, and state management that's empowering organizations to derive insights from data as it arrives. So in a final conclusion, we have to focus the convergence of big data integration and data warehousing and real-time data warehousing that represents a significant paradigm shift in data management. By leveraging big data technologies and real-time processing capabilities, organizations they can unlock valuable insights, drive innovation, and stay ahead in today's data-driven world we can create. As we continue to witness advancements in technology and the proliferation of data resources, the journey towards a comprehensive and real-time data warehousing is bound to evolve further. It's enabling organizations to thrive on an increasingly competitive landscape. Okay, my dear students, I hope you have enjoyed the fourth session of the topic of advanced data warehousing techniques. Thank you once again, and thank you all, my dear students. Good morning, my dear students. Good morning, one and all. Welcome to the fifth and final session of the course. The topic name is Advanced Topics in Data Visualization and Data Warehousing. We need to talk and finalize. So, unlocking insights, that's advanced data visualization and warehousing for machine learning and artificial intelligence (AI). The realm of machine learning and artificial intelligence (AI), data visualization, it serves as a powerful tool for uncovering insights. It is interpreting research and communicating findings effectively. As these fields continue to evolve, so do the techniques and approaches to visualizing complex data and model inputs. As part of the lecture part, we will delve into the advanced topics in data visualization and data warehousing, specifically tailored for machine learning like ML and artificial intelligence AI applications too. The first point, visualizing model performance metrics. One of the critical aspects of machine learning and artificial intelligence is evaluating the performance of trained models. Visualizing models' performance metrics that provides a comprehensive understanding of how well a model generalizes to unseen data and helps in identifying areas for improvement. Like a common metrics such as like accuracy, precision, and recall, and F1 store, and ROC cows, this is ROC cows that can be effectively visualized using various techniques. For instance, interactive dashboards that can be created to dynamically display changes in performance metrics across different model iterations or hyperparameter configurations, as well as heat maps and confusion metrics that offer intuitive visual representations of a classification performance, highlighting areas of correct and incorrect predictions too. As I told on a earlier lecture, there is a time series plots that can track the performance of models over time. It's providing insights into their stability and robustness. Okay, second will be on interpreting machine learning results through visualization. We need to talk here. So interpreting the results of machine learning models is very crucial for understanding the underlying patterns and making informed decisions. Visualization that plays a pivotal role in this process by transforming complex model outputs into actionable insights that stakeholders can grasp intuitively. Techniques such as future importance tools, partial dependent plots, and SHAP, that is Shapley additive explanations, and that value visualizations provide insights into the factors driving model predictions. Actually, these visualizations help in identifying influential features, that's understanding their impact on predictions and detecting potential biases or anomalies in the model behavior. Moreover, we can say techniques like a LIME, that is local interpretable model agnostic explanations, that generate local explanations for individual predictions. It's offering transparent insights into how the model arrives at a specific decisions level. Visualizing these explanations enhances model transparency and fosters trust among users and stakeholders too. Second will be on visual analytics for AI-driven insights. Okay, in the era of AI-driven insights, visual analytics, it combines the power of machine learning algorithms with interactive visualizations to extract the actionable insight from a large and complex data sets. This interdisciplinary approach that integrates techniques from data visualization, statistics, and machine learning to enable users to explore data, uncover the hidden patterns, and gain a deeper insights, we can say here. And so for example, we can say techniques such as like a clustering and a dimensional reduction algorithm, example, like a TSNE and PCA, that can be combined with interactive visualization to identify the clusters or patterns within high dimensional data. And interactive dashboards that are equipped with the filters, slides, and drill down capabilities, it empowers users to explore data from different perspectives and extract the meaningful insights efficiently. Furthermore, we can say advancements and developments in natural language processing, that's NLP, and sentiment analysis, it enables the visualization of textual data. It's opening a new avenues for understanding a customer feedback, social media trends, and other unstructured data sources too. So in short conclusion, we can say in the rapidly evolving landscape of machine learning and artificial intelligence, advanced data visualization and data warehousing techniques are indispensable for extracting insights, interpreting results, and driving informed decision-making level. By leveraging the power of visualization, practitioners can unlock the full potential of their data, that empower stakeholders with actionable insights, and pave the way for transformative advancements in AI-driven approach and applications. As the field continues to evolve, staying abreast of the latest trends and innovations in data visualization, it remains a paramount for realizing the full potential of machine learning and artificial intelligence AI. And the next topic, that's the power of data visualization. It's looking like unlocking a business insights. In today's data-driven world, businesses are constantly striving to gain a competitive edge by leveraging the vast amounts of data at their disposal. However, simply having access to data is not enough. It's very crucial to interpret and understand the data to make informed decisions. And this is where data visualization comes into play. It's acting as a powerful tool for business intelligence, that's a BI. In this part of the lecture, we will explore the significance of data visualization in BI, that's a power business intelligence, and how it can drive a business success here. And some of the key performance indicators visualizations we need to talk, that is a KPI visualizations. So key performance indicators like KPIs are essential metrics that help businesses gauge their performance and progress towards specific goals. Visualizing KPIs is vital as it follows stakeholders to quickly grasp the current status and trends without delving into complex data sets. By transforming raw data into visually appealing charts, graphs, or dashboards, KPI visualizations, it provides actionable insights at a glance. For example, a sales dashboard that might display KPIs such as like a monthly revenue, conversion rates, and the customer acquisition cost through intuitive charts. This visual representation, it enables sales teams to identify areas for improvement, track performance that against targets, and make a data-driven decisions to optimize strategies. Second point, that is visual analytics for business decision making, we need to talk now. Visual analytics, it goes beyond a basic data visualization by incorporating interactive elements and advanced analytics techniques. It empowers users to explore data dynamically, uncover hidden patterns, and derive a deeper insights into support strategic decision making. Just imagine a scenario where a retail company wants to analyze a customer purchasing behavior. Through visual analytics, they can create interactive dashboards. Okay, they can create interactive dashboards that segment customers. It's based on a demographics, buying preferences, and shopping habits, everything. By visually exploring these data sets, the company can identify the lucrative market segments, tailor marketing campaigns accordingly, and enhance the overall customer satisfaction too. The third is, integrating data visualization with the Power BI platforms. It's a very important stage. To harness the full potential of data visualization, businesses often integrate with the BI platforms, that's the Power Intelligence platforms. And these platforms, it serves as a centralized hubs for collecting, analyzing, and visualizing data from various sources through business intelligence. It's providing a comprehensive view of the organization performance too. So integrating with the BI platforms, it offers several benefits, including like centralized data access. Users, they can access the relevant data from multiple sources with a single platform. Okay, that's very important stage, ensuring a consistency and accuracy. And according to the scalability, BA platforms, they can handle large volumes of data. It's allowing businesses to scale their analytics efforts as they grow. And the customization is very easy, so users can customize dashboards and reports to suit their specific needs. It's incorporating tailored visualizations for different departments or stakeholders. So by seamlessly integrating data visualizing with the BA platforms, businesses, they can streamline the decision-making processes, drive operational efficiency, and gain a competitive edge in today's dynamic marketplace. In a conclusion, data visualization, it plays a pivotal role in transforming raw data into actionable insights for business intelligence. Whether visualizing KPIs, conducting visual analytics, or integrating with the BA platforms, leveraging the power of data visualization, it empowers businesses to make informed decisions, drive innovation, and achieve sustainable growth in an increasingly data-driven world. Okay, the final concept, that's navigating the cloud. That's a cloud computing discussion and guided to data warehousing in the digital era. In today's data-driven world, organizations are constantly seeking efficient and scalable solutions to manage the data and analyze the data. They are ever-evolving volumes of data process. Traditional on-premises data warehouses are no longer able to keep up pace with the demands of modern business environments. So just enter the cloud data warehousing solutions. It's offering a flexible and a cost-effective alternative to traditional infrastructure. As part of the slide, we will delve into the realm of data warehousing in the cloud. It's exploring its overview, benefits, challenges, and best practices for successful implementation and management. The first will be an overview of cloud data warehousing solutions. Cloud data warehousing solutions such as like AWS Redshift, Google BigQuery, Azure Synapse Analytics, and Snowflake, that have revolutionized the way organizations store, manage, and analyze their data. Okay, that's why I have explained some example softwares. And these platforms leverage the scalability, elasticity, and cost efficiency of cloud computing to provide on-demand resources for storing and processing large volumes of data. They offer a range of features including like automated backups, high availability, scalability, and seamless integration with other cloud services, that's making them attractive options for businesses of all sizes. So what are the benefits of a cloud data warehousing? Starting from the scalability, cloud data warehouses, it can easily scale up or down, that based on changing business needs, ensuring optimal performance and cost efficiency. According to the cost savings, by eliminating the need for upfront hardware investments and ongoing maintenance, cloud data warehousing solutions, it offers significant cost savings. According to the flexibility, cloud data warehouses, it support a variety of data types and workloads. It's enabling organizations to handle diverse analytical use cases. And next is agility. With the cloud-based data warehouses, organizations, they can rapidly deploy new analytics projects and iterate on existing ones, accelerating the time to insight. Final will be an integration. So cloud data warehouses, it seamlessly integrate with other cloud services and tools. It's facilitating data ingestion, transformation, and analysis across the entire data ecosystem. Okay, what are the challenges of the cloud data warehousing? We need to talk some other points. While cloud data warehousing, it offers numerous benefits, and it also presents a certain challenges that organizations must address, starting from the data governance, ensuring data security, privacy, and compliance in a multi-tenant cloud environment. It requires a robust governance policies and controls. Second will be on a performance optimization, optimizing query performance and minimizing latency in a distributed cloud environment. That may require a fine-tuning and optimization. The third is a cost management. While cloud data warehousing offers cost savings, organizations must carefully monitor and manage their cloud usage to avoid unexpected expenses. Okay, some of the best practices for migrating to and managing cloud-based data warehouses we need to talk and finalize. Successful migration to and management of a cloud-based data warehouses, it requires a careful planning and execution. Here are some best practices to consider, starting from the access your needs. Just to conduct a thorough assessment of your data requirements, workloads, and analytics. Some of the use cases to determine the most suitable cloud data warehouse solutions. Second, that is a plan your migration, or just to develop a comprehensive migration plan, including like a data migration strategies, schema design, and performance optimization techniques too. The third will be an optimize for performance, just to fine-tune your cloud data warehouse or configurations, data modeling, and query performance to achieve optimal performance and scalability. That is fourth will be on implement the data governance, so establish a robust data governance policies and controls to ensure data security, privacy, and compliance in the cloud. Final, that is a monitor and manage cost, so just implement cost monitoring and optimizing strategies to manage cloud expenses effectively, such as like utilizing cost allocation tags, right sizing resources, and leveraging reserved instances too. So in a conclusion, cloud data warehousing solutions, it offer organizations the flexibility, scalability, and the cost efficiency that are needed to meet the challenges of today's data-driven world. By understanding the benefits, challenges, and best practices that are associated with the cloud data warehousing, organizations can harness the power of the cloud to unlock valuable insights and drive a business innovation. So whether you are considering migration to the cloud or already managing a cloud-based data warehouse, adopting these best practices can help you maximize the value of your data sets and achieve your business objectives in the digital era, my dear students. Okay, my dear students, I hope you have enjoyed the fifth and final session of the topic of advanced topics in data visualization and data warehousing we have discussed here. Thank you once again, and thank you all, my dear students. Good morning, my dear students. Good morning, one and all. Welcome to the another session. The topic name is Capstone project that's applying for big data concepts we need to talk now. So unlocking the power of data, a comprehensive discussion to project planning and data analysis. We need to talk some of the levels and points now. So in today's data-driven world, businesses and organizations are increasingly turning to data analysis to drive a decision making and gain a valuable insights. However, before diving into data analysis, it's very crucial to lay a strong foundation through effective project planning and meticulous data preparation. This part of the lecture, we will explore the key steps that's involved in project planning, data collection, and analysis that's equipping you with the knowledge to unlock the full potential of your data. The first step, we need to talk about the project planning and the scope definition. That's defining a project objectives and the deliverables we have to talk now. Every successful data analysis that a project begins with a clear understanding of its objectives and expected deliverables. Whether it's improving operational efficiency, optimizing marketing strategies, or enhancing a customer experience. So defining a precise goals is very essential for guiding the analysis process. So by establishing SMART goals, that is a specific, measurable, achievable, relevant, and time-bound objectives, stakeholders, they can align their expectations and ensure that the analysis efforts are focused on delivering tangible outcomes. So according to the identifying data sources and analytical techniques we need to talk, this is the second level. So once the project objectives are defined, the next step is to identify the relevant data sources and analytical techniques necessary to achieve those objectives. This involves assessing the availability of data within the organization or on sourcing external data sources if needed. Moreover, selecting the appropriate analytical techniques, whether traditional statistical methods or advanced machine learning algorithms, that depends on the nature of the problem and the type of insights out. So collaborating with the data scientists and the subject matter experts, they can help in making informed decisions that's regarding the choice of analytical approaches. The second point, we need to talk about the data collection and the preparation. So starting level, that's gathering and cleaning data for analysis. Data collection, it involves acquiring, extracting and consolidating data from various sources, including databases, APIs, spreadsheets and external sources. However, raw data is often messy and unstructured, containing errors, inconsistencies and missing values. So data cleaning is a very critical step that involves identifying and rectifying these issues to ensure the accuracy and the reliability of the analysis. And the techniques such as like data imputation, outlier detection and standardization, these are common employed to clean and prepare the data for analysis. Second is ensuring a data quality and integrity. So maintaining data quality and integrity throughout the analysis process is paramount to obtaining a trustworthy insights. This requires implementing data validation checks, documenting data transformation steps, and establishing data governance policies too. By adhering to best practices for data management and quality assurance, organizations they can minimize the risk of making decisions it's based on a flawed or incomplete data, thus increasing the reliability of their analysis outcomes. The third level, that is data analysis and interpretation. So starting from applying statistical methods and machine learning algorithms, we need to talk. With a clean and well-prepared data at hand, analysts they can now proceed to apply a range of statistical methods and machine learning algorithms to extract meaningful patterns and relationships from the data, from a descriptive statistics and hypothesis testing to regression analysis and clustering techniques. The choice of analytical methods that depends on the specific goals of the analysis and the nature of the data. So machine learning algorithms, including like classification, regression, and clustering algorithms, it offers advanced approaches, that's advanced capabilities for predictive modeling and pattern recognition. It's enabling organizations to uncover hidden insights and make a data-driven predictions too. And final level, that is interpreting results and drawing insights. The final stage of the data analysis process, it involves interpreting the results that's obtained from the analytical models and drawing actionable insights to inform a decision making. So visualizing techniques such as like charts, graphs and dashboards, it play a crucial role in presenting the findings in a very clear and intuitive manner. Moreover, effective communication of the insights to stakeholders is very essential for driving organizational change and realizing the full value of the analysis. By translating complex technical findings into actionable recommendations, data analysts they empower decision makers to make informed choices and drive a business success too. So in conclusion, we can say project planning and data analysis are integral components of any successful data-driven initiatives. By following the systematic approach outlined in this specific lecture mode, organizations can harness the power of data to gain valuable insights, optimize operations, and drive innovation. Remember that the journey from raw data to actionable insights, it begins with the careful planning and ends with informed decision making. So stay tuned for more insights and recommendations on mastering the art of data analysis. Okay, my dear students, I hope you have enjoyed another session of the topic of Capstone project that's applying a big data concepts. Thank you once again, and thank you all my dear students.